Okay, this is a short video on operator precedence and associativity within the Python programming language. So precedence refers to which operators are evaluated first, or which operators have a higher level of precedence. So we'll see that in a table here in a moment, but basically there are operators that will be evaluated before other operators based upon the level of precedence they have been assigned within the language. Now, associativity in Python is maybe not quite as big a deal in Python as other languages, and basically what associativity is if there are multiple operators in a statement that have the same level of precedence, in what order are they evaluated? And the order would be either left to right as they appear in the statement, or right to left. And the reason I said it's maybe not quite as big a deal in Python is because most operators are evaluated left to right. Exponentiation, star operator, is one of the examples that is right to left. So we have what's referred to as a precedence table, and these are level of importance or level of which operations are performed. And at the very top of this, we have parentheses. If you want to force things to happen in a certain order, or you want to be very clear what order of evaluation you have within a statement, you can place parentheses around that. So if it's going to be evaluated in an order other than what you would like, put parentheses in the statement to get it the way you would like it. The next is exponentiation. So within parentheses, those statements are evaluated, and then if there's any exponentiation in the entire statement, then that will happen next. Next, we have some operators that I think are not quite as heavily used, which is the unary plus, the unary minus, and bitwise not. So the unary plus and minus would be like if you were writing a statement and you were going to write 5 plus 3, and you put plus 5 plus 3. So putting a plus sign in front of a number, obviously that wouldn't necessarily be required and is extra typing. The unary minus is if you want to represent a negative number. So if you said x plus minus 3, for example, that would be an example of unary minus. And bitwise not is taking a value that is a series of bits, and the bitwise means you go through a bit at a time. So you go through a bit at a time and basically flip that bit. So, if it's a 0, it becomes a 1. If it's a 1, it would become a 0. Next in our table is some of the more common arithmetic operations. The first set is multiplication, division, integer division, and the mod operator. The next is addition and subtraction, plus and minus. Next in the table is bitwise shifts. So you can take a binary value and either shift it left or shift it right, is what the two operators there are doing. And as you shift bits, one bit will fall off, and then if the bit coming in will be a 0 value. Not necessarily something that we'll probably use in this class, or at least not use a lot. Next is bitwise and. CIT 161 is not a prerequisite for this course, I don't think. But if you've had any networking courses, when you're applying a subnet mask to an IP address, you do a bitwise AND. So, in what I do, that would be probably the most common use I would have for the bitwise AND. Next is bitwise exclusive OR. The OR operator truth table, if you have A and B, is the expression A or B is true if A or B is true. So in that truth table, all the combinations evaluate to true, with the exception of both values, A and B in this case, being false. Now what exclusive OR is the expression A exclusive OR B is true if A or B is true, but not both. So in that truth table where we have two falses, that would be false. Where we have two trues, that would be false. And then where we have one false and one true, the result of that operator would be true. We have bitwise OR, where you take two values and you apply the OR operator bit by bit within the two values. Next we have what are referred to as the comparison, the identity, and membership operators. And as we continue on, we then have the logical operators have the lowest level of precedence within Python, and their order is logical NOT, followed by logical AND, followed by logical OR. So that's the precedence table for the operators in Python. What we'll do now is look at an example and how you can kind of walk through this, if you will. So here I assign values to A, B, and C, and then I have an arithmetic expression that I want to calculate. And I need to know what the precedence of operators is to come up with an answer. So the first thing you do when you're walking through this is you first substitute in the values for the variables. So if I do that, this expression becomes 2 plus 4 times 4 minus 6. And if I look at this in my table of precedence, what's going to happen first is my multiplication left to right. And in this case, I only have one multiplication, which is right here. So I perform that operation. So 4 times 4 is 16. So I now have 2 plus 16 minus 6. Again, if I look at the operators I have and my precedence table, addition and subtraction are the same level of precedence, and their associativity is left to right. So that means first thing I would do is this addition, and if I perform that addition, I come up with 18. Continuing on, I now have this minus, and 18 minus 6 is 12. You may remember from, I don't know if it was elementary school or middle school, when you hear that addition and subtraction are associative. What that means is it doesn't really matter what order. So what I've shown here is the way Python would evaluate this. But if for some reason I did the 16 minus 6 first and got 10, and then 2 plus 10 is 12, I would come up with the same answer. If the operators are associative, that's true. If they're not associative, that is not true. So, if you're looking at this and trying to figure something out, you really need to follow the Python operator precedence regardless of whether or not an operator is associative or not. So that's operator precedence, operator associativity, and an example to demonstrate this.